Hi everyone, we are back with another video. Today, we will deepen our knowledge of machine learning methods. Our topic for today is the random forest, which is a well-used method in machine learning. So far, we have covered quite a number of machine learning models, including logistic regression and decision trees as supervised learning methods. We learned the theory behind the methods and also their work in practice. You can see those videos using the link above. Let us start. We start with recalling the decision tree method, since the random forest is built on decision trees. Decision trees are supervised learning algorithms where they are used for both classification tasks and also regression tasks. The method segments the predictor space into regions using splitting rules. At the end of the segmentation, you obtain many regions and you will use these regions to make predictions. For instance, if it is a classification task, when you are given an observation, you first find the related region that the test observation falls in. Then, you can use the mod response value of the training observations in that region. For regression tasks, you again find the related region, then you can take the mean value of the training observations in that region. As you remember, there are roughly two steps in building a tree. First, we use the training data for dividing the predictor space into j distinct and non-overlapping regions. Our goal is to obtain the regions that minimize the residual sum of squares, that is the summation over regions and observations in the related regions yi minus y hat rj square. In this formula, yi values are the true values of the observations and y hat values are the predicted values over region rj. Next, we will pick a feature xj and a splitting point s that minimizes the RSS value. As you may guess, there are many possibilities for j and s values. We will pick the ones which decrease the RSS value the most. Mathematically speaking, we are looking for the j and s values that minimize the summation. This is a division operation. We need to repeat this process iteratively so that we further minimize the RSS value. The process continues until a stopping criterion is reached. For example, we may continue until no region contains more than 5 observations. After the division, we use those regions for predicting the test observations. As you remember, growing a classification tree is very similar to a regression tree. However, the difference is that classification trees are used for predicting a qualitative response rather than a qualitative one. The way to grow a classification tree is the same. We will split the whole space into regions, and we do this recursively. However, this time we cannot use residual sum of squares. Alternatively, we can use the classification error rate, which is given as 1 minus maximum of p hat mk over k. Here, p hat mk is the proportion of training observations in the mth region that are from the kth class. There are two other measures that are preferable in practice, which are called Gini index and entropy. The Gini index is defined as the summation over k classes p hat mk times 1 minus p hat mk. The other alternative error measure is the entropy, which is given by again the summation over all k classes p hat mk times log p hat mk. After selecting the error measure, the procedure is the same. We are going to find the regions that minimizes the error value by picking a feature xj and a splitting point s. We continue to repeat this process iteratively so that we further minimize the error value until a stopping criterion is reached. We continue to divide the space. After remembering what decision trees are, now we can move on to random forest models. An ensemble is an approach that combines many simple models in order to obtain a single and potentially very powerful model. Sometimes we call these simple models as weak learners, since they may lead to mediocre predictions on their own. Random forest is also an ensemble method, where The weak learners are regression or classification trees. Random forest builds many decorrelated trees and then combines them to create a potentially powerful model. Now we will see how to grow decorrelated trees. Assume that we have a dataset of p features, so there are p different independent variables in our data. Remember that in decision tree, we check over all p features and possible split points over those features. However, it is not the case when growing a tree for random forest. In random forest, each time we select a random sample of n features is chosen as split candidates from the set of full p features. Generally, m is taken as the square root of p. In other words, the number of features considered at each split is approximately equal to the square root of the total number of features. So each time a splitting operation in the tree, we are not allowing the algorithm to see the majority of the available features. By doing so, we believe that we eliminate the strong features and other features will also have more of chance. Here is a visualization of a random forest model. As we said earlier, we grow many weak learners, namely trees. The thing is that if you use only one of the trees, you probably will not get great accuracy results. However, combining them boosts their predictor power and decrease the variance significantly. Hence, the resulting method becomes more reliable. Note that the training phase can take quite some time as you need too many decision trees. This can be given as an example of the cons of the random forest method. Now we will show you how a prediction operation is done. Assume that you are given a test observation. As you have gone through the training process, you have a random forest model that has a bunch of decision trees. First, you input your test instance to the decision trees that you grew. As a result, each tree will generate a prediction for the test instance. Now, it's time for aggregating the predictions of the decision trees. If it is a classification task, you can do voting and select the majorly voted class. However, if it is a regression task, you can simply take the average over all predictions that weak learners generated. Based on the voting or the averaging, you attain your final prediction of your random forest model. This is how a prediction is made in random forest model. Today, we covered random forests, the structure, and the way of growing weak learners. We saw the way of making predictions. Lastly, we briefly discussed the pros and cons of the method. We are looking forward to your feedback or questions. Thank you for watching our videos. Please do not forget to hit the subscribe button. By doing so, you are really helping us to grow. You can always ask questions by leaving a comment below and we will be happy to answer it. In our next video, we will cover other ensemble methods in tree methods, bagging and boosting. See you in the next videos. Bye bye.